We're still on 11.3 and 11.4. Exponential functions and logarithmic functions. Yes, I think I mentioned we're going to do 2 videos. Actually, we have 3 videos for these 2 sections. So this is the part 3 of these 2 sections. In previous video, we covered example 1 in the notes. Now we're going to look at example 2. Example 2 has 4 problems. Example 2. Solve equations. Number 1, 2 to the power of x equals 1 over 8. All right, let's see how do we solve this equation. This equation is an exponential equation. Why? Because it has an exponential function on the left-hand side of the equation. This is how do we handle this type of exponential equation. Some books call this type of equation elementary exponential equation because the form of this type of equation is pretty simple. The solution, the way to solve it is also simple. We look at both sides of the equation. Left-hand side is 2 to the power of x. And the right-hand side happens to be a power of 2 as well. Could we write 1 over 8 as the power of 2? Let's try. We know 8 is the power of 2, right? 8 is a cube of 2. We know that. And 1 over 2 to the power of 3 is 2 to the power of negative 3. Does that make sense? Because the reciprocal of the quantity can be written as the quantity to the power of negative 1. For the power rule, we multiply 3 and negative 1, we have 2 to the power of negative 3. So 1 over 8 can be written as a power with base 2 as well, 2 to the power of negative 3. This type of exponential equation, as I said, sometimes is called elementary exponential equation, is very easy to solve. By looking at both sides of the equation, you can identify both sides of the equation happen to be able to be written as the power with the same base. Base is 2. Base is 2, right? And on the left, the exponent is x. On the right, the exponent is negative 3. So if the two exponentiation equal to each other, and they have the same base, shouldn't they have the same exponents? Corresponding parts equal to each other. 2 equals 2, then x supposed to be equal to negative 3. So that's how do we get x equals to negative 3. Is that easy? Yeah, pretty straightforward. Again, we call that type of exponential equation elementary exponential equation. This type of equation has both sides, could be written as the powers with the same base. And the solution is pretty simple and straightforward. Let's look at number 2. The equation is log with base 25 and times 5 equals x. This equation is a logarithmic equation. It's an equation. It has a log in it, so we can see it as a logarithmic equation. How do we solve this equation for x? I give you a moment to think about it. We are not very familiar with logarithmic functions compared with exponential functions, right? But what's the connection between the two? This equation is in the logarithmic form. Did we just went over in previous video? We just covered how do we convert an equation from a logarithmic form to its equivalent exponential form, right? Yeah, we're gonna apply that method. We are going to convert this equation to its equivalent exponential form. What's the base? Base is 25. What's the log? Log is x. Remember, log is on the shoulder, a piece of wood. A piece, P-I-E-C-E, P, a piece, P, a piece of wood, W-O-O-D, yeah. Log can be, log cabin, it can also represent, can also means a piece of wood, right? So log is on the shoulder of base, equals anti. We only have three parts in the equation. We already used the base and the log. Of course, anti is going to be on the other side. By the conversion, the equation is written as 25 to the power of x equals 5. And it's an exponential equation. Actually, it's a elementary exponential equation because right-hand side is 5 to the right-hand side is 5 to the power of 1. Right-hand side is 5 to the power of 1. Left-hand side, we know 25 is 5 squared, right? Then 25 to the power of x would be 5 to the power of 2 and then to the power of x. That gives us 2 to the power of 2x. Yeah, that's a trick. In the beginning, we applied the trick, convert this equation to its equivalent. Also in the so you might, what's